In this lecture, we are going to discuss the significance of design patterns in software development. Design patterns are reusable solutions to common problems in software development, offering ways to write consistent, maintainable, and effective code. They address recurring challenges by providing tried and tested structures, ensuring efficient problem solving and clarity in design. Patterns like the builder and the factory method simplify object creation, while the singleton ensures a single instance for shared resources. Resource management RAII ties resource handling to object lifespans, enhancing reliability. Composite patterns manage complex structures like trees, and visitor patterns allow new functionalities without altering existing classes. By applying these patterns, developers streamline coding practices and building new robust software systems. In this lecture, we explore some of the most common design patterns, explain their purposes, and provide real-world examples of how they are used in practice. Now, first of all, let's discuss about the design patterns. Design patterns are basically a tried and tested solutions to recurring problems in software design. They provide developers with a way to solve problems efficiently and ensure code follows a consistent structure. These patterns have been documented in resources like famous book design patterns by Gamma and are widely recognized as a critical part of the good software engineering. The builder pattern is used when constructing complex objects. Sometimes using constructors to create objects can be limiting, especially when we need flexibility. The builders class helps solve this problem by allowing step-by-step object creation. For example, Java String Builder and HTTP Request.Builder let developers build objects gradually and customize them as needed. The key advantages of this pattern is that it separates the process of object creation from its actual structure, making the code cleaner and easier to maintain. The factory method pattern is a way to create objects without specifying their exact class. Instead, a factory method returns the appropriate object based on the situation. This approach allows developers to add new subclasses without changing existing client code. For example, in Java, the method charset.forName UTF-8 uses this pattern to return the correct charset. By using factories, developers can simplify object creation and support polymorphism more effectively. Resource management RAII is an essential part of programming, especially for handling memory files or logs. The RAII resource acquisition is initialization pattern ties resource management to the lifespan of objects. When an object is created, it acquires the resources, and when it is destroyed, its resources released automatically. This is seen in C++ with tools like unique PTR and logguard. In Java, we try with resources, and in Python with the with statement. This pattern reduces the chances of resource leaks and makes the code more reliable. The singleton pattern ensures that a class has only one instance throughout the program and provides a way to access it easily. To implement this, the constructor is made private and static method is used to manage the single instance. This pattern is often used for managing shared resources such as configuration settings. However, it has drawbacks like difficulties in testing and potential threat safety issues, making it use controversial in some cases. The visitor pattern helps add new functionality to existing classes without modifying them. This is achieved by creating a visitor interface that defines method for each type of class. Classes then accept visitors, delegating the new functionality to them. A real-world example is Java's file visitor, which handles different types of files systematically. This pattern makes it easy to introduce new operations while keeping the existing class structure intact. The composite pattern is useful when working with structures like trees where both parent and child nodes needed to be handled uniformly. This pattern defines a common interface for all the components where their individual elements are composed of other components. For instance, in a tree structure, both parent nodes and the leaves can implement the same methods like calculating depth or checking if a value exists. This pattern makes the system easier to extend as a new component can be added without changing existing code. Static analysis for quality is a method to check source code for errors and quality issues without running it. Tools like linters and compiler warning help identify potential problems such as dead code, unhandled cases, or null pointer errors. By incorporating static analysis into the development process, teams can catch issues early and maintain high code quality. Style guides and automation. Style guides ensure that code across a team or project looks consistent and is easy to read. Automation tools can enforce these style rules automatically, saving time and effort. For instance, tools can reformat code to match the desired style or flag areas that need attention. Combining style guides with automation make it easier to maintain code quality over time. Thank you for watching, and I hope this helps you in your software development journey.